This presentation is about evaluating artifacts. In particular, we will look into goals and strategies for such evaluations. A very basic question is why we carry out evaluations. And there are many different reasons for evaluating and many different goals for evaluating. And we will look into a few of these ones. Here are the two basic goals for any evaluation. First, we should determine to what extent the artifact solves the problem. And typically this is the explicated problem, but sometimes we also go back to the original problem and check to what extent that one has been solved. Furthermore, we almost always also look into the requirements and determine to what extent they have been fulfilled. Now, someone might come up with an objection here and ask, why should we care at all about the requirements? The requirements in themselves, they are not important. They are just a bridge between the problem and the artifact to be constructed. The requirements, they help us to design, but in themselves, they are not important. So we should really only care about determining if the artifact actually solves the problem. Okay, this is not a bad argument, but in practice it's often quite difficult to determine if the artifact really solves the problem and to what extent it does so. It's typically much easier to go for the requirements and to evaluate them and to check if they have really been fulfilled or not. So practically, it's quite useful to care about the requirements. Here are two other goals for evaluating artifacts. The first one is about comparison. Sometimes we don't only want to evaluate an artifact in isolation, we also want to compare it to similar ones. We want to find out in what respects our artifact differs from other similar artifacts. Yet another goal is to investigate the side effects of using our artifact. We don't only want to know whether our artifact actually solves the problem, we also want to know if the artifact has any unintended and undesirable side effects. For example, if we are developing a new medicine, we don't only want to know if that medicine is effective in curing some disease. We also want to know that the medicine is safe, that it doesn't hurt the patients. It's also useful to distinguish between formative and summative evaluations. Formative evaluations are those that are carried out in order to help us to learn more and to improve further design. So, formative evaluation means that we take an artifact while it is still under design and we evaluate it, we gain some knowledge about it, and based on that knowledge, we go back to design and can make the design of the artifact even better. Summative evaluation, on the other hand, it means that we take a final version of the artifact after we have done all the design, and then we evaluate it in order to arrive at a conclusive assessment. So this is at the very end of a design research project. The figure here to the right gives an example. Say that we have a chef and that he tastes some soup. Then he makes that while he's still cooking, so he can add on more salt or more spices and thereby improve the soup. So this is formative evaluation. But when you put the soup on the table for the customer, then there is no more chance to really improve that soup. So then it is just to arrive at a final assessment. So this is an example of a summative evaluation. When we are to evaluate some artifact, we need to have some overall plan or some approach to do that, or in other words, we need an evaluation strategy. In this section, we're going to look at different evaluation strategies along two dimensions: ex ante versus ex post, and artificial versus naturalistic. Let us start with the ex ante versus ex post dimension. And this dimension has to do with the actual use of the artifact to be evaluated. In general, ex ante means before the event and ex post means after the event. And in this context, the event we're talking about is the use of the artifact. So ex ante, it means that the artifact is evaluated without being used before this use, and ex post means that the artifact is evaluated in use after being used. Well, it seems that ex ante evaluation is a bit strange. Is it really possible to evaluate some artifact without using it? It seems that you would need to have the artifact in your hands, so to say, and then start using it, and only then would you be able to evaluate it. So what could it really mean to evaluate ex ante before you use the artifact? Well, the idea here is that instead of working with the real artifact, you work with drawings and sketches and blueprints and models and descriptions of your artifact. Different things that you produce during the design and development activity, and that help you to later on construct the actual artifact. And it is possible to evaluate these early things in the design process. Here's an example of an ex ante evaluation for a computer game. The idea is that you evaluate the game without actually playing it, and maybe the game hasn't been completely designed and developed and implemented yet. So instead, you look at drawings and sketches and models of this game. For example, you can look at concept art or artwork or storyboards or characters, and based on these, you evaluate the game without playing it. Ante evaluations offer both advantages and disadvantages. One advantage is that ex ante evaluations often can be low cost because you don't have to actually use the completed artifact. You can simply look at sketches and models and drawings and so on. This can also be done quickly, and this is also a reason why ex ante evaluations are appropriate for formative evaluations. You can carry them out in an early stage to low cost and quite fast, and this means that you can get an early feedback which helps you to produce even better versions of the artifact. A big disadvantage, however, is that it's a high risk of false positives. That is, you might get too optimistic results from an ex ante evaluation, because the devil is often in the details, and they will not become apparent until you have the actual completed artifact. If you only look at models and drawings, problematic aspects can hide. Here is an example of an ex post evaluation for a computer game. It means that the game is evaluated in use when it is being played. So players are actually playing the real computer game. The researchers can then observe the players when they are playing. They can also interview the players afterwards, and they can study documents such as logs from the actual playing. You can say that the advantages and the disadvantages of exposed evaluations, they are the mirror images of those of ex-ante evaluations. So exposed evaluations are often expensive because you need to have your completed artifact and you need to put it into use. It can often be slow. You need to carry out studies around this actual using, for example, an actual playing of a computer game. So high costs and pretty slow. But the exposed evaluations are very helpful for summative evaluations when you have your completed artifact and you want final conclusive assessment. There is also a lower risk of false positives. You may not be over-optimistic because the respondents, the people using it, are actually using it in some situation, and problems will then appear during this use. It cannot really hide as easily as in an ex-ante evaluation. Let's now look at the other dimension of evaluation strategies, that is artificial versus naturalistic evaluations. An artificial evaluation means that you evaluate an artifact in an artificial setting. So you as a researcher, you construct some specific setting in an artificial way. For example, inside a laboratory, you're using some simple toy problems, and the people that are engaged here, they are not real practitioners. Could be students, for example. A naturalistic evaluation, on the other hand, it means that you evaluate an artifact in a real and natural setting. That is, real users using real systems to solve real problems. Now, this distinction between artificial and naturalistic evaluations, it may sound very binary, but in fact, it is a continuum here. In one and the same evaluation, you can combine both artificial components and naturalistic components. For example, you could have real users that are working on some toy problems, or you could have real users that are working on real problems, but in some laboratory setting, for example, in a classroom. So in practice, you often combine both artificial and naturalistic components. Here's an example of an artificial evaluation for an EHR system. That is an electronic health record system. It's about collecting and storing health information about patients in a digital format. It could be information about diagnosis or treatments or symptoms or medications or different kinds of images. And an artificial evaluation of such a system, it could be that you have some medical students, they're using the actual system and they perform some simple task during a seminar. So we see here that we don't have real users, instead we have students. Okay, the system is the real one. It is the EHR system that is intended to be used. It's not a real problem, it's just a simple task, and it is in an artificial setting, so it is during a seminar. So overall, this is quite an artificial evaluation. Here are some advantages and disadvantages of artificial evaluations. First, they are typically fast and low cost because you don't have to engage real people or real users in a real setting. Instead, you can set up your own laboratory environment or some other artificial setting, and this can typically be done quite fast and to a low cost. Another advantage is that you can often get high internal validity because you can completely control your artificial environment. so there will not be any unexpected events or any confounding factors that come into play. But a disadvantage is that you have a high risk of false positives, because you may exclude some factors that are problematic for your artifact. They may not come into play in your artificial setting. An exercise here is to think about how these characteristics work out in a laboratory when you test drugs. Please take a few seconds, few little time before you move on to the next slide and think about this case. Here is an example of a naturalistic evaluation, again for this EHR system. And it could mean here that you involve physicians and nurses, and they are using the system for performing their daily tasks, and they do that in their ordinary clinical practice for a few days. So here we have real users, the practitioners, we have the real system, and we have a real problem in terms of the daily tasks, and it is an ordinary practice, an ordinary environment, not an artificial one. And here are advantages and disadvantages of naturalistic evaluations. One disadvantage is the high cost. You need real users, real practitioners, and that will typically cost a lot. It's often slow because you need to evaluate and monitor and observe the practitioners for some time, interview them afterwards, and so on. Another issue is that you need access to the practice and to the practitioners, and that can be difficult in many situations because practitioners are typically very busy in their day-to-day work. An important advantage here, on the other hand, is that you will get high external validity, because when the evaluation is carried out in a real environment, its results can most often be transferred also to similar environments. And there is a low risk of false positives, as the evaluation is performed in a real environment. Many different factors and problematic factors will actually pop up, and if the result is still positive, you can be pretty sure that it is so. And finally, please take a little time and think about this case of testing drugs in a clinical environment. That's a naturalistic evaluation, and think about these different characteristics in that situation.